Hi everybody, Adam Steele here, and today I'm going to try and answer a question that I get quite a lot, which is, what's the difference between microphone level, line level, speaker level, guitar level, and what's the deal with these? So this video is not sponsored by a sponsor. This is brought to you by me and our supporters over at Patreon. So if you would like to thank the channel by supporting us through Patreon, that would be really appreciated. Anyway, let's get on to these. This is a guitar cable. This is a microphone cable. They can both do more things though, and there are other types too. These are TRS cables, often called stereo cables, but these are also generally used for line level. And this are both speaker cables. So before we start talking about the cable types, let's talk about the different levels and why that's important. So the first kind of two levels, and I'm going to talk about two levels at the same time to try and differentiate them. I'm going to talk about microphone level and line level. Line level is generally in a studio what we would ideally love just about everything to be, which is a relatively strong signal that can be transmitted from one box to another box. And line level is generally somewhere around 1 volt. It can be 5 volts, it can be half a volt, it changes depending on the level of the signal you're sending, but it's roughly somewhere in that range. It doesn't have very much current attached to it, not very much power, because it doesn't need it. All it's really doing is sending a relatively strong voltage across a line from one device to another, hence the name line. The reason we nominally use 1 volt or 5 volts or round there, 5 volts would be a very loud line level signal that might actually cause a little damage to non-professional gear, but let's say 1 volt then, is that it can be sent a relatively long way and it will get to the other end of the cable and it won't pick up huge amounts of noise, theoretically, on the way. The reason that microphone level is different is down to the way that microphones work. Let's take as an example the good old SM57. Most engineers know them, most of us have got 1 or 10. Ribbon microphones work in a very similar way, where what's actually happening is that as we speak, or a guitar or a drum or whatever makes noise, that physically moves something inside a copper coil, or with a ribbon, it's the ribbon moving, connected to something, and that makes a teeny tiny minuscule little voltage. We're talking maybe 0.1 volts, 0.01 volts, 0.001 volts. We can be talking in the range of 1 millivolt, which is 1,000th of a volt, which is a tiny amount of voltage that is coming out of this thing. And that is really going to need to be beefed up if it's going to work in all the devices that we use, like mixers, like equalizers, compressors, any other sort of technology that we're going to use to process anything like this, mix it in with other signals like a PA system. They work really well at line level. Again, the reason that it's line level is that we can do things like combine signals or compress them or EQ them or whatever, and they will come out relatively unscathed. But to get this to a line level, we need to use a preamplifier. We'll get to amplifiers later. That's to do with speakers, but a preamp or preamplifier is the thing that takes this tiny little signal and bumps it up by maybe 1,000 times. Just to get nerdy for a second, we use decibels to work all this out, and it's a logarithmic scale, which, if you aren't aware, the formula for decibels is 20 to the logarithm power 10, which means, if you don't want to understand any of that, that's fine. What that means is that 20 decibels of gain on a microphone level might take it from 1 millivolt to 10 millivolts. 40 decibels of gain might take that to 100 millivolts, and 60 decibels of gain would bring that to 1000 millivolts, which is 1 volt, which is line level. So it might be that something like this, if it's a relatively quiet source, that's why you might be getting 60 decibels of gain on your preamplifier, on your preamp. That is to get a relatively quiet, not very sensitive microphone up to line level. That's also why ribbon microphones sometimes need even more, like 70 or maybe 80 decibels of gain, because they're so super quiet on an electrical level that you really need to be bringing that up. And it can be quite an expensive thing to do in certain designs, especially classic designs, because they were trying not to bring noise, electrical noise, up with that. Now, microphones like these that have circuitry inside, mostly condensers, electrets, all the kind of the more advanced fancy stuff, those still operate at microphone level, but they have 48 volt phantom power being sent from the preamplifier to them. That's nothing to do with the sound, that's not to do with line level, that is just to power some of the electronics that are inside these microphones that make their pickup design, whatever that may be, work as intended. Because some of the more delicate microphones, condensers that we often use for vocals, all that kind of stuff, they need some very special kind of conditions inside the microphone to make them operate in a way that makes things sound really nice. Of course, some microphones can kick out a lot more level than others. They're what we call more sensitive microphones. But even then, the most kind of loud microphones that you can get still really don't come up to line level, so you would still need to use a preamplifier. So you'd be going from mic level to line level. Now, on the other side of things, we want to go from line level to speaker level. And those are two very different things again. The speaker level is very high power, very high current, and generally quite high voltage too. We're talking over 10 volts. Anywhere from 10 volts to 100 volts, or maybe even more, is what happens inside guitar cabinets, PA speakers, big loud things that push a lot of air. They need to be that high, and especially have a lot of current, because they need to physically drag a magnet and a copper voice coil and push air. You might have heard the phrase moving air. If you've ever put your hand in front of a subwoofer when it goes really, it's physically moving a lot, and that has to come from somewhere. So where we were talking about a preamplifier before, which was taking a really tiny microphone level signal to a line level signal, where we talk about amplifiers, which is usually short for power amplifiers, we're taking something that's nominally 1 volt and taking it up to that speaker level, which is way bigger, way more powerful, and needs a lot more oomph. Again, using a technical term. Now, what I've not talked about yet is a guitar level, because that's a little bit of a different thing. It kind of is like a microphone level, but it's not quite the same thing. And because of the way that a guitar traditionally works, which is essentially a copper coil around a magnet connected to one of these, that is connected to the front of a guitar amplifier, again traditionally, which has a thing called impedance. And the way that a guitar works is it works in a tuned circuit. And that means that there's a thing called resonance, which is why the high end of guitar pickups kind of comes across a certain way. It's kind of like tuning a drum, but electrically. We have a thing called impedance, which really we want to be really high in that guitar circuit. The voltage is really, really tiny, much like a microphone signal, but also we're having to try and tune that circuit so that the high end doesn't sound dull and really kind of muffled. That's why a lot of audio interfaces now have an instrument mode, even if they have the same jack connection for line level and guitar level. They will change to present a really high impedance to a guitar, which means that it then sounds the way it's supposed to sound. Talking about jacks, that brings me onto these things. This is a guitar cable And this is a line level TRS cable. Can I use this one with a guitar? Yeah. Will I get great results with it? Maybe, but you are taking risks because of the way that they're designed and their purpose. And this is a speaker cable, and that's a guitar cable, but they look the same. What's going on? It's to do with the internal design. A speaker cable is designed to handle that really high voltage, really high current, so the middle of this cable is quite a thick piece of copper that's designed to take lots of power, lots of wattage, and not get too hot. There is more to it, of course, but that's what it really boils down to, is if you use a guitar cable, which usually they're kind of quite thin on the inside, and you put 1,000-watt speaker signal through that, it might not be very long before this starts to melt. And when that melts, then you're going to have some serious problems because your amplifier is not connected properly, and boom. However, a guitar cable is designed in such a way that, like I said, it's quite thin on the inside for the tip connection, which is the bit that carries the signal down the cable, but around that there's usually a very thick, very kind of well-designed shield that is a metal kind of shield that makes sure that the minimum amount of noise from the outside world gets picked up by this cable, because a long cable is basically a radio antenna, and we really don't want that. And guitars only have two connections, one for ground and one for the signal. That's where this one comes in. This is a TRS cable. A lot of you will have seen these and thought this is a stereo cable, and this can be used for stereo, generally speaking, in non-professional environments, home environments, or maybe with headphones, where one connection, the big sleeve thing, is the ground, and then on headphones, the two bits that connect would be left ear and right ear. But in a studio, in a professional environment, we use these a lot for line level, and what we're doing is using a thing called balancing. Balancing is also what we see on microphone cables. Microphone cables being designed quite similarly to guitar cables, with that kind of shielding with the ground, and then two instead of one thin cables going through the middle, same as the TRS cable. Now, balancing is a whole different thing and is not to do with the level of the signal. The level, the voltage is one thing, and balancing is a completely different thing. The balancing is where we send the signal down the cable twice. Once, we're sending it forwards, and essentially the other one we're sending it backwards. That's me dumbing it down a little. We're inverting the polarity of one of the signals, which means flipping the voltage upside down. So one's going plus, minus, and the other one is going minus, plus. It sounds bizarre because it kind of is, but the reason is any noise that gets through the shielding, the third part of the cable, any noise that gets through there is then picked up by both cables, the hot and the cold, as we call them. Quite often inside the cable you might see that one's red and one's white or something like that. And because they both pick up that noise, when they get to the end, that signal is then turned back into an unbalanced signal by flipping that out of phase one, the inverted polarity, back to normal. And what happens is any noise that was picked up is then backwards on one signal and forwards on the other, and that means they cancel out, which means that that noise that was picked up magically disappears. Now, that only works in the situation where you have something sending a balanced signal that has been balanced by that piece of gear, whether it be a preamplifier, whether it's an EQ, compressor, anything like that, and you need a balanced cable, and you need the other piece of gear on the other side to have balanced inputs, which means they will then internally unbalance the signal before they do any other processing with it, which then means that the work is done in 3 stages and magically removes any noise, which can really be useful if you've got really long microphone cables on a stage, Or if you've got to send your line level signal, like sometimes I might have to send something from my patch bay over to the effects rack, back through something else, that balancing is really useful. Back to why we use this and this, as this is a guitar cable, this is a speaker cable. It is really annoying, it's really irritating, and it can cause a lot of issues. It just kind of happens that, especially guitar amplifiers, we've really kind of stuck with this being the connection for speakers. That goes back to the 60s and 70s with, you know, vintage Marshall amps and Fender amps and all that kind of stuff, using these, and that's become kind of a tradition that is difficult to break from in the guitar industry. Whereas in the bass amp industry and the PA industry, we tend to use this. This is speakon. So what's the difference between this and this electrically? There isn't one. Inside, in terms of the connection, they are the same. In terms of being able to handle high power, they don't need shielding really in the same way that a line level or a mic level would need it, because the voltage and the current that are being carried on this are so phenomenally large in comparison to the mic and the line that any noise that creeps in would be minuscule in comparison to the signal being sent through these. So why do we use this and not this? Well, this one, as you can see, doesn't have any exposed connections on the end. I could kind of lick this like an ice cream and it wouldn't shock me and really hurt me. This one, if it had a 100 volt, 50 amp kind of, you know, massive, 5,000 watt signal going through it. I mean, that's a bit much for this cable, but the point stands. If I was to then put my tongue on that, that would really hurt. I mean, not that anyone's going to do that, but you know, they're trying to think of safety. And this you plug into an amplifier or a speaker and you click and it locks, which means in the middle of a show, there's no way that that's going to come out, which means that it's not going to blow a speaker, blow an amplifier, stop the show. It's going to keep things going. There are more advanced versions of speakons as well, because a traditional jack speaker cable has signal. On this one, it's gold tipped and it has the ground, or the negative. This one generally will have that as well, but you can get these with what they call 4-pole connection. This is a standard 2-pole one, so it's got kind of speaker and its ground. But you can have one that's got 2 speaker connections going through the same nice thick chunky cable, which means either you can have the sub and the top going through one cable for nice neatness, or you could have left and right going through one cable and then split out. Maybe the left goes straight into the speaker and the right chains out. Maybe however you would want to do that. In a PA system, that might not be how you do it, but you might have 2 subwoofers with separate amplifiers going through the same cable or something. I don't know. There's even an 8-pole version where you can get these super thick cables that will run one cable, and that will have 4 completely different signals on there. So you could have an entire side of a PA system, a big PA system, running off one single thick cable. So you've not got a whole ton of these being kind of snaked around everywhere. You've got one simple connection. But yeah, mic level, line level, amplifier level, or mic or guitar level. But that's why we have preamplifiers, then we have amplifiers. Because the preamplifiers, generally speaking, are, especially in the pro audio world, trying to bring the really tiny signals up to line level, and then we do all this kind of processing at line level. Then we go out to amplifiers, which make big noise. And so that's kind of the long and short of it. I'm sure there are things I'm missing. I mean, the XLR that's used for microphones, we can send line level down these too. That's why a lot of the monitors I have, like these Eve Audios, they have XLR inputs. That's because they want to be balanced, and also the XLR connection locks, which means that means there's an extra kind of point of benefit. And if the cable that you're using is not long enough, you can link them together, much like you would with a microphone. If you want to use a microphone cable for line level, that's usually fine. If you want to use a line level cable for microphone, again, as long as it's properly shielded and balanced, that's usually fine. I have a drawer full of adapters and gender changes if I'm caught short. Like quite often, like I've got this Audient Nero, the monitor controller here, and everything on the back of this is TRS, you know, the 3-part jacks. These, because if it was to use XLR on the back of that, that would have to be twice the size, which is impractical. So they use TRS, and I've been having to adapt a couple of these, using one of these, which is a balanced adapter, to XLR to feed the Yamaha power amp I've got, to feed the crossover that I've got, which is a whole thing for another video. But that's still a line level balanced signal using just a different connector on the end. So when it comes to line level and mic level cables, generally you can swap them. Guitar cables you don't really want to be using because they are, by their very definition, unbalanced, which means that if there is any kind of noise that's going to creep in, it's going to be on that cable. I know this is something that guitarists struggle with all the time because, unfortunately, guitars don't have a way of sending a balanced signal. It kind of sucks, but that's the way that guitars are. Maybe if somebody designed an active kind of circuit buffer thing inside a guitar with a 3-pronged output, you might be able to get a balanced signal, but then all the guitar effects pedals are all unbalanced as well, so that's its own issue. But then once that gets through to the guitar amplifier, that's still unbalanced. Yeah. But then if you're using something like an Axe FX or a Kemper or something, the output from that is usually balanced, because then that goes off to a PA system that might be 60 to 100 meters away through a snake, you know, through a balanced snake that goes all the way back to a mixing desk that could be at the back of an arena, say. I know a lot of the time those guys use digital stuff now, but it has to become digital somehow, and you want to have the minimum amount of noise. So mixing kind of mic level and line level signals, they generally all tend to use the same cables anyway, as long as they're balanced. But mixing line level and speaker level, no, don't do that. If you use an unbalanced speaker cable instead of a guitar cable, you might get away with that, but the chances of you picking up lots of noise is quite high, because these are not designed with lots of shielding, they're designed with lots of core to handle lots of power. Whereas the other way round, if you use a guitar cable instead of a speaker cable, that's when electrical faults, booms, fires, problems can occur. I hope this has been informative and useful for you. Stick around, we'll be talking about why I've gone back to using the NS10 style speakers that I'm using here as my mains. I'm going to be talking about a lot of Dolby Atmos stuff coming up soon, and that whole can of worms, and trying to break down what it actually is, because there is that whole thing to talk about. Yes, I'm going to be talking about the tech setup of getting 11 speakers in here with a 7.1.4 system. But what does that mean? What does that mean for listeners? What does that mean for producers and mixers? That's going to be a whole thing. So thanks everybody for watching, and there's so much more on the channel. Hope you stick around. I'm Adam Steele, and I'll see you in the next video. Goodbye.